Hello, we're going to talk about networks. So what is networks here? A networks here is two or more than two computer devices connected together with software and hardware. Hardware typically cables, software, for example, Ethernet. That's IEEE 802.3, 1980. February, study group 3. So that's Ethernet technology, standard, software standard. Network, maybe it's easier to understand why network here. So why we want to have a network? To sharing resources here. For example, if I have a class room with 24 computers and one printer, we're going to share that printer. How can we share that printer for 24 computer users? Network. Without network, I would need to have a printer for each computer. That will be 24 printers and 24 computers. When 24 computers are used by 24 students, that printer, most of the time, are not used. There will be a big waste of money and space. Sharing resource is why we need to have network. If you have a network and ask you, what are you sharing? You say, hey, nothing. We don't share nothing. Then why you want to have a network? If you share nothing, it makes no sense at all. You have to share something to have a network. Talking about wireless network, we all use Wi-Fi. So you ask people, what's Wi-Fi? People know what's Wi-Fi. At home, you use Wi-Fi, then you can sit in front of your TV, play your computer. You don't have to sit against the wall where they have an outlet to use your computer. That's Wi-Fi. You go to the airport, they have Wi-Fi, then you can use it. So remotely connected network, that's Wi-Fi. The very first network is actually a wireless network. That's an Ethernet. Designed by Xerox. Xerox right now is famous for their paper and copy machine. Long time ago, that was a very, very creative company. They had created the very first network in Hawaii. Hawaii, some big islands, many, many small islands. You would agree with me, a wireless network would work better for this so many islands. Hawaii, the very first version of 802.3 is a wireless network. After that, we use wired network. Used for company, you inside of the company building, why they want to have wireless? When just run some cable, make it wired, will be easier. And later on, the company said that we have visitor. The visitor come to our company, they want to use Wi-Fi. Then you said, hey, we only have wired. You cannot use it. It's no good. You have to provide those visitors a Wi-Fi. So here comes, we have a wireless network for the visitors. You work for a company, you go to your office, your computer is hardwired to a network. Then you go to a meeting with your notebook. Your notebook, you can use company's wireless network. Many, many companies nowadays have both a wired network and a wireless network. You may consider the wired network is the main network, and the wireless network is the secondary network, or one for employees, one for guests, serve different purpose, or one for fixed when you are in your office, one for remote when you are in a meeting room. That's the wireless network. Thinking here is you don't want to think the wireless network is here to replace the wired network. Not like that. They are both used and both needed for different purposes. See this picture here. Network allows many users to connect to a central computer to access information and communicate. What we are sharing? We are sharing a central computer. We're sharing the info. If you don't need to share, you don't need to have a network. Internet. So who created the internet? When I say who, that may be an organization. The organization who created internet in 1969, or roughly speaking, 1970, was DOD, Department of Defense, US government created internet. For what purpose? At that time, the government had some military computer, say one in New York, one in LA, one in Dallas. They all need to have identical info to be updated so the computer will be useful. How can we update those info? When you are going to add some more info, maybe some people need to pick up the phone and read it to New York, to LA, to Dallas. People there say, hey, write this down here, enter this to the computer. We're going to have hexadecimal, very long string of hexadecimal, like 2A, 3C, 4, 5, B, 3F, keep going. Chances are people are going to read it wrong or heard it wrong or type it wrong here. Not a good situation. What are we going to do? We're going to have something nowadays we know as an email, so we can send to the 3 location, and there's an attached file, so the people there can just download the attached file. In this case, no mistake can be made during this transportation. That's called internet. We need something nowadays we call internet. At that time, we don't know the term internet. And the government, they don't have the expertise to create an internet. They ask professors at school like USC, Stanford, Westside to create this called DARPA. It's a project for the government. So they did. It works. It works, then government have the first network to be used for military computers. After about 10 years, say around 1980, business world, like IBM, say, hey, I want to use it. How about that? I also want to use it. I have different location business computers. I don't have military computer, but idea will be the same. They all need to be updated with info, with data. Can I use it? The government say, yes, you can use it. How can I use it? They publish the TCP protocol, IP protocol. That's how you use it. That's like you're thinking about a format and the rules of using it. They copy those under the IETF, Internet Engineering Task Force, IETF.org. If you go to IETF.org, you still can see those TCP/IP spec being published there for IBM, yes, and for everyone. Everyone can use it. Anyone in the world, you go to IETF.org, find original TCP, original IP, and updated version of TCP and IPs, and follow that. That's your internet. And the standard here, TCP/IP, one is like 791, One is like 793. That's a standard number. I use it all the time while I was in the industry, so I remember. With those info here, you type in those numbers, and those numbers is under we call RFC. So what is RFC? Request for comment. You type in, they ask you go to IETF, Internet Engineering Task Force.org. You're going to see somewhere they have RFC, request for comment. You type in 791, 793, you're going to see TCP and IP. What is RFC? RFC is request for comment. Before they published as a standard, they send it, this committee send it to, say, IBM and other company for comments, request for comments. After the comments, they finalize the document, they still call request for comment 791, 793, and some other numbers. So you said that, hey, yeah, I want to see the TCP or IP, but I don't know what number is assigned to them as an RFC, request for comment number. You don't. So what are you going to do? You just Google. You Google TCP, RFC, they're going to tell you right away. Wikipedia, most likely, you're going to find it. They tell you, oh, that's RFC 793, IP, that's RFC 791, something like that. Then you go to IETF.org, you enter. You're going to see the original and updated TCP IP spec. When I was in the industry, I worked for MCI, that's a carrier. And we have switch, telephony switch, phone machine from Ericsson and Nortel. So there's some problem, it's not working. So based on the TCP IP, I send out a trouble report to those two, we call manufacturer, phone companies. Say, hey, according to TCP IP, your telephony switch should work this way, but you did not. You need to fix it. That's my base. Company based on the standards to design and to do the testing. I can never say that based on Wikipedia, your phone machine should work this way. Wikipedia is a good starting point, but it's not used for design or testing. Have you created some info under Wikipedia? I did. I created something under Wikipedia. And it's pretty much like FYI, for your reference only. It's not like a standard. Standard have to be published under standard body. Nowadays, with internet, you don't go to the library, you go to internet, you find it. And internet spec is published under IETF, Internet Engineering Task Force.org. It's free. If you don't know IETF, then you say that I know everything about TCP and IP. No, you know nothing about TCP and IP from a standard perspective. Okay, World Wide Web. At that time, long time ago, we have World Wide Web. That's internet. A portion is called World Wide Web. Another portion is not World Wide Web. The difference for that is World Wide Web have more functions. A non-World Wide Web have less functions. So many companies want to say that my company is ABC. What is your URL, your internet address? I say www.abc.com. That's better. That was a long time ago, 20, 30 years ago. Hey, that's cool. Today don't have to. Today don't have to be. So if I ask, what is your company's URL, website address? You say it's xyz.com. Do I need to ask you in front of XYZ, do you have www. Yes or no? No, I'm not going to ask you that. That's tedious, that's unnecessary. I use the browser, Google Chrome, for instance. to type in xyz.com. Should your company have www, the Google Chrome will try, because I type in xyz.com, they'll try and say, no found. Let's try www, found it. The other way around, I type in www.xyz.com. Your company don't have www. Then the Google Chrome say not found. Let's try it without www. Just trying xyz.com, found it. In this case, the browser will worry that for me. I don't need to worry about that. I don't want to know that. But something else is called HTTPS. You see that? TCP, the last one is P. IP, the last one is P. HTTP, the last one is P. P means protocol. So what is protocol? Protocol is how we're going to treat a timed event. That's called, we all agree the way we should be treat a timed event. That's protocol. For example, if I my computer send a request to a printer, say, hey, where is my printout? The printer will come back and say, I don't know what you're talking about. What do you mean by what is your printout? That's request. Where's my printout? That's called timed event. Timed, based on previously what happened. What happened is you send me a print request. After a while, you send me a, where is my printout? It's not like I never sent you anything, then I ask you, hey, where is my printout? Make no sense. Another scenario, my computer send out something to get printed. Later on, send out a request, ask where is my printout. That makes sense. You see the two different scenarios. The first one, you ask, where is my printout? Make no sense. The second one, you ask, where my printout? That makes sense. Maybe in the queue, maybe already printed out. The same event, where is my printout? Going to be treated differently based on previously what happened. So protocol is timed event. We both agree how we're going to treat the time event. When we say we both agree, the computer and the printer, they both agree. Once I send you something, once I ask you, where is my printout? The printer would come back say, I don't find your printout, or it's in the queue, it's already printed. Or those three answers can be expected here. So how are we going to treat it? So that's called protocol. TCP/IP is a protocol. So maybe understanding a little bit about TCP/IP will be easier to understand this internet. If you said that I understand the internet technology, but I have no clue whatsoever about TCP/IP. No, you don't understand internet at all. So what is TCP/IP? TCP is a number. Okay. If I want to mail you a letter or a Christmas gift, how about that? I like Christmas. I like gift. I mail you Christmas gift and I write down your address. That's TCP. You receive, okay, that's for mine. That's the same idea. The server sends something to your computer with an IP address, not somebody else's computer, because we all have IP address. Address, that's your home address. That's how I mail gifts to your home address. Now we have TCP, we should be happy. Why IP? IP is a sequence number. In this case, is how many gifts you have mailed to me. Christmas season, I mail a gift to my friend in New York. My friend picked up the phone and called me, say, Dr. Wu, how many packages have you mailed to me? I say, 1. Have you received it? The New Yorker says, yeah, I have received 1. But how would I know? You only mail me 1 gift. one package. You maybe mail me more, right? I say, no, I have only mailed you one. Then the New York said that last year you mailed me two. So I thought this year you're going to mail me two. Well, yeah. There's some difficulty in our communication, as you can see. Next year, if I mail you one gift, that's one package, or two gifts, that's two package, in addition to your TCP, that's your mailing address, what I'm going to do, I'm going to do some IP to you or for you. Then you're not going to call me. So what is that? Next year, if I'm going to mail you two gifts in two package, the first one will have your address and will have one of two. The second one will have your address, will have two of two. Then you should be happy, right? Address A, that's for me. One of two, two of two. Okay, you send me two gifts in two package. If next year, I'm only going to send you one. Still going to have your TCP, that's your home address. You see, that's for me. And I'm going to mark one out of one. Then you say, okay, this guy only sent me one. No questions asked here. So what is this one out of one or one out of two, two out of two? That's your IP address. As you can see from this example, this analogy, TCP and IP are both needed. Thinking about, simply put, TCP is your home address, IP is item, how many items during we'll call transaction, how many packages in this transaction. Transaction in here is Christmas gift. How many Christmas gifts you have sent it to me. Email, the very first internet application is email and attached file. Only email will not work that good. Remember, we talk about business or military base, we need to update some info. Send you an email with an attached file. You can just download attached file. That's very long hexadecimal, 123C to B4D, something like that. That's attached file. So email and attached file, they are the very two first available internet applications. Nowadays, are we still using it? Yes, we are still using it. It's very, very useful. The most useful two applications for internet were introduced first. Cloud computing, we talk about the cloud, Cloud means internet. I don't know, whoever created this term say cloud. Okay, internet is cloud, cloud is internet. Nowadays, you may have, using your iPhone or other phone, taken too much of pictures and you don't have enough in memory. And some provider, cloud service provider will ask you, hey, put it under our cloud. We're not going to charge you, or we're going to charge you a minimum amount of money, and you can put a lot of stuff. That's called cloud. Okay, you say, okay, let me try. A cloud, you take a look of the sky here, you see some cloud. Your stuff is actually there. No, nothing like that. Your stuff will be in a we call server. Server is a type of computer in the cloud service provider server. So what's the difference between server and compute and my PC? Your PC is your personal stuff. And the server, they don't have like a PowerPoint software so you can make a PowerPoint. No, they don't have a browser so you can Google in something. No, just server. It's just like a big database and identify each items by the users and can be sorted, can be located. That's a server. So server is a big database. They have physical software, physical hardware, just like your computer. Like I saw a server, it's a Dell server. look from outside, it's identical. Just look like a Dell PC. No, it's a server, a system box here. System box I'm talking about. Depends on the inside, not depend on outside. Depend on inside if you have all the, for instance, school, all the student info in this computer. You say, hey, this is my PC. No, this is not your PC anymore. It's a server. Server. So what is server? Client and server. You go to a restaurant, say server, you can think about like waiters, waitress. You go to a restaurant, they may have 5 waiter or waitress. How many people? 100 guests here. Each waiter or waitress is going to serve 20 guests here. So that's a server idea. You get it? Yeah, server is share. Huh? Those 20 guests going to share one waiter or waitress here. So that's called server. That's an analogy here. Computer is common sense in a way, if you understand. If you're trying to think about some analogy here, then that'll be easier for you to understand, and it's really similar to that. Also talking about social media, we are using more and more social media nowadays, like Facebook, Instagram, and so on and so forth here. Social media. Social media, you want to use it for social purpose. You don't want to use it for work purpose. Some company do use social media to promote business. Even a law firm, I know, do that. But as an employee to a company, you want to use social media carefully. You're going to use social media to go there, say that I work for company A, B, C, X, Y, Z, and all my boss are stupid. They treat me unfair. I hate this company. You know what I'm talking about, right? You can do all those kind of stuff here. Then your company fire you. Can they fire you? Of course they can fire you. You say, no, I have my freedom of speech. Check it one more time. So what is the freedom of speech? You go knock your neighbor's door. Your neighbor come out. You insult him or insult her. Verbally insult him. Can your neighbor bring you to the court? Of course, yes. You say, no, I have my freedom of speech. I can talk whatever you want to talk. Not like that, not like that. You talk bad about your company under social media. You talk bad about your neighbor. Once your neighbor opens his door, you're going to get sued. You may not go to the jail. You may get fun. You pay some money. So let's come back again. Where is my freedom of speech? The freedom of speech is a Constitution amendment says that you can criticize the government and you're not going to be punished because of that. Government. You can criticize. You can go outside, go down the street and say that I don't like my president, so and so, he's not smart, he's stupid, something like that. The government will not and cannot do anything to you by law. That's your freedom of speech. It's not to your neighbors or to your company, to your employer. No. So make sure you understand your rights here. Don't get it wrong here. Okay, that's your social media. Use social media for social purpose. Don't use it for work purpose here. It's not a media for you to go there and to yell at anybody else here. Talking about different type of computers, say personal computers. As I mentioned before, the very first computer was invented by IBM. So what does IBM stands for? IBM stands for International Business Machine. Now, a few people know that. You know that. You don't know that. Make no difference. International Business Machine. That's IBM Incorporation. IBM invented the very first business machine called IBM 360. I used that 40 years ago when I was a student. I use that because that's the only computer in the world. We have to learn those IBM 360. Science is huge. Going to occupy one room for that. They have punch card. You do some punch card stuff here. Computer at that time was kind of slow. Was kind of memory space was limited, but that's just the beginning. On the right track here, then you can go much faster here, Computer bypass the human, I'll say maybe 20 years ago, 30 years ago here. 30 years ago, I wait on my computer, my PC. I'm twisting my thumb here. Oh, you're slow. Today, my computer wait on me all the time. That's your CPU. Memory space. 20 years ago, open up system box and, well, sorry, the correct term is system unit, and to add a memory chip to the motherboard because memory is not big enough. Today, they're huge, they're big. And also you can keep it under the cloud. It's like unlimited. It's not that expensive. So that's not a problem. Personal computer. Later on, IBM invented the first personal computer, PC. And that's we call a desktop computer. Later on, they have this we call notebook. Notebook is portable. Desktop is not portable. It's too heavy. You cannot carry it. And they also have something. In the future, computer will look like you only have I/O. It's like you only have I/O. Input will be like keyboard, touch screen. Output will be a screen. You're not going to have operating system, memory, CPU. You don't have it. So what are you talking about? I'm talking about the future computer. You only have I/O. So where is my CPU? Where's my memory? Where are all those good software tools like PowerPoint software? Where are those components? They are all under the cloud. We have a service provider. Say, hey, this is your PC service provider. Okay. You use a keyboard and a monitor and software to connect to internet. Once you connect to internet, based on your user profile, they know you are a Apple user. They'll make your computer an Apple because you're going to use Mac OS and all the apps in Apple, you're familiar. And for someone else, it's Windows, based on your profile. They'll make your computer Windows. So would that be a good idea? Yeah, they only charge you some limited amount of money. Good idea, good idea. Yes and no. Yes, good idea. No. Then you don't have privacy. Your info is under their control. They can see your info. Of course, supposedly they're not going to pick on your info, but who knows? And they are responsible for your info. They lost it. The damaged here is on their side, not your side. Your side, you got a computer, you drop your computer, whoa, that's it. That's on you. So the term here, or the thinking here is where. Where is the component? Components still needed, CPU still needed, memory still needed, software like PowerPoint, software still needed. Where are we going to locate those components? In the cloud, service provider side, or at your hand? That's the thinking for the new computer. It's not like the new computer not going to have a CPU, no memory, no software. It's not like that. They're all there, but in somewhere else. So that's a new computer. In here, we talk about two types of computer, desktop computer and laptop computer. The differences here is desktop computer is big, and notebook computer or laptop computer is small, portable here. And they have a pros and cons. In case you got some desktop computer problem here, system unit, you fix it. It's easier, it's big. And you have a notebook, you want to open it up, try to fix something, it's difficult. So you may need to buy another new one. And also the desktop computer is cheaper. You're cheaper and can be fixed easily. And notebook is more expensive, difficult to fix, but it's portable. Depends on what you want. Okay, so that's stuff here. They also have a convertible laptop here to show you, and some other ultra portable computers, make it very smaller. That's also a pros and cons here. Make it smaller here. You go outside for a business trip, you still need to do your work. Then you have a very light, very small computer. When you carry, it's nothing. But when you use it, it's maybe difficult. Yeah, it's small, it's too small, screen is too small, and the keyboard is too small. You need to have a little bit tiny fingers to type it here. So that's a pros and cons here. And actually, next generation computer is not going to look like that. They have some lighted keyboard. I don't know if you see it or not. The size here is like your mobile phone. So you go to a meeting, you use like your mobile phone to have light. When the light going to on your table, you're going to see a lighted keyboard here. Then you touch the table here. You can do the typing. They can make it big. With the same thinking, can we make it our screen, we call monitor? Of course you can. So later on, maybe your mobile phone will also embed your notebook. Okay, you put your mobile phone there, you have two lights, one light on the table, that's your keyboard, very big, or normal size. Another light, wall, that's your monitor, that's your screen. Want to make it big? Hey, you have a PC being embedded or included in your mobile phone. Is technology there? Yes. Then what are we waiting for? We are waiting for the companies to give us that. Technology, we are always behind the technology. That's a business decision. They're thinking about, maybe not so many people want that. You say, why is not? Why not? I mean, to me, it's good. You have less privacy, would you say that? If you use your notebook, people around you, I mean, may not be able to see what you type or what you're looking at. You put it under a table, under a wall, well, everybody's going to see it. That's pretty much like a privacy issue here. So something is good. They have some side which we want to consider. That's always the case. One example about technology is Google. Google at one time, they have a Google Glass. Google Glass, you can wear in the glass, look like a glass. Then you can like blink in your eyes, something like that, video recording, or touch a little bit here. You can video recording. Is it good? Good, I like it. I'm wearing the glass, so I'm adding one more functions. Whenever I need to video recording something, that's cool. They stop the project. You cannot buy one. They don't want to sell you one. They don't make one. Technology is finished. Then why don't they want to make one? Some consideration here is a privacy here. Now you're wearing that Google Glass. Google Glass here, then you touch a little bit, then you can video recording, you go to a casino, you'll be video recording everyone. Well, someone were not supposed to be in a casino or with someone else, then those guys may sue you. Or they may sue the Google. The company don't want to get sued because of that here. So that's something. Thinking about you can video recording everything. That's good, but you're going to violate the privacy or the rule here. You go to the casino, you ask those guys work in the casinos, hey, can I, whoa, this is cool, so pretty. Can I video recording something? Can I take some picture? No, you cannot. You cannot here. People want to go to casino. People want to have their privacy. So think about that. Think about technology, thinking about the privacy and the legal concern here. Chromebook, yeah, this is a new notebook, Google Chrome. So the Google have their own notebook recently. Whoa, multi-user computer. This is a fancy term here. Say the computers, this is a big computer going to be used for different servers, a different purpose here. Well, I can give you one example. That's called multi-user computers here. When I was with MCI, a phone company, and MCI had prepaid card. Today you still have it. That's a long distance call. You purchase a prepaid card, you pay money, then you can make a long distance call. Once they run out the points in the car will no longer valid. The database we use is BHM. That's a company in Omaha. They have this big computer. And this computer you can think about is like a database, basically. They serve MCI prepaid card. They serve MasterCard. They serve American Express, the credit card. The identical computer database. A portion is serve different company for different purpose. I'm giving you examples. That's a real example. One for a phone card, one for a credit card. That's different. So that's called multi-user computers, the term. Server, network server. Server, you see the right-hand side of the picture here. Each DAC, you can consider that's like one server. So that's many servers here. So hey, before server, what do we have? We have mainframe. IBM have mainframe. Nowadays, we still have many business companies, like the bank. They are using mainframe. IBM mainframe. Computer, the size used to be, you need to have a room to accommodate. Nowadays, it's like a freezer. It's not that big. IBM mainframe. A mainframe computer, you say that this is for the bank. Bank, we have 10,000 customers. All the info are there. Then you're going to ask one question. Should this computer corrupted, crashed? 10,000 people. Can I use it? True. But it's very reliable. The chance for that is very slim. And later on, we have this client and server idea. Client and server idea said that the same 10,000 customers, instead of one mainframe, one computer, we're going to use 10 servers, like 10 computers. In case one computer malfunction, we still have 9 computers can take over the customers. We're not going to lose anything. Maybe a little bit slower. So that's client server. Client server. Analogy is if you are using a mainframe idea, it's like you go to a restaurant. You only have one waiter or waitress, and the rest of them are guests. In case this waiter and waitress need to go home or have something, well, nobody going to serve the guest. But the chance here is very slim. You say, I'm going to have 5 waiter or waitress to serve the guest. In case one waiter or waitress need to go, I have 4. Maybe a little bit slow, you need to wait, but we're fine. thinking from this analogy, you will say that, whoa, I like the client server idea. More computers, then in case one computer got a problem, we can use some other computer to back it up. Yes, but the business world, some bank, they're still using mainframe, one computer. The computer is reliable. Software-wise, they can pick up another software. Hardware-wise, they can pick up another hardware. In case one software or one hardware fail, the backup going to be there. Unless you use a hammer to smash it. Whoa, they have a security guard, they have the building, they have all kind of security from you, preventing from you to do that here. So it's very, very reliable. Would you change that? If you were the decision maker for the bank, would you change from one computer's mainframe computer to client server? More computers. I don't know about your decision, but decision being made by many decision makers of the banks is we're going to keep it the same way. Because we cannot take the risk to switch the system. In case something goes wrong, we cannot afford that. So we're going to keep using the way we have. That's a business decision. Good decision, huh? So you will know. Then you don't want to think about, we only have server, network server, client server. We don't have mainframe. Or the client server, the server are here to replace all the mainframes. They are not. They still have some mainframes computers used in the business world here for that purpose. Now, I think we understand the servers. And what is a server? Show this server side-by-side installation in server rack. So many server. Mainframe computer, as I mentioned, just one computer do it all. Server. So you say servers as many computer. Thinking about this guy here. So 1 server, 2 server, 3 server, 4 server, 5 server. It's many server. Amazon using a server. They don't use one computer and one computer only called mainframe. They use server. So how many servers, computers are there for Amazon? Many, right? Supercomputer is here. They give you example for NASA. It's not for us. It's not for business. It's for this purpose. NASA, they need a supercomputer, can do a lot of calculation, very fast, huge amount of data. So the airspace can arrive, can come back. That's a supercomputer. We also need a supercomputer to do the weather broadcasting. Say tomorrow, the chances of rain is 50%. Sometimes people say, so what do you mean by 50%? Half and half, huh? Maybe rain, maybe not. Well, it's not really like that. It's not really like that. 50% and I'll say 90%. So 90% is more, so you better chance to get rain, right? So it's not half and half. It's not like that. See, last one. Oh, embedded system and IoT. So what is embedded system? Embedded system, embedded is included, like a mobile phone. That's an embedded system in terms of camera. Digital camera is embedded. That's called embedded system. That's one way. Actually, another term called emergent. Emergent, combine more functions into one device. Another one here is embedded. At home, you have alarm system. So when intruder came, your alarm going to sound. So this is embedded. What do you mean by embedded? Inside, they have some computer software memory chips here to make it happen. So that's called computer embedded home security system. So it's two different ideas. This is called, they have a term called IoT. You talk about Internet of Things here, this term here. There are so many terms here. Some terms have a consensus, meaning people know it and people have the same idea. Some terms, they don't. like just IoT, people don't have a consensus here. So if you talk to me, say, Dr. Wu, do you know anything about IoT? I'm going to say that, spell it out for me. You're going to say Internet of Things. I'm going to say, can you give me an example? We don't have a consensus. I'm not quite sure what you're talking about and what I'm thinking about are the same. Need to make sure we are on the same page first. So that's a term. Many terms here. You just use the term people have consensus and don't use a new creative terms. Some people create it. You say, oh, this is a cool term, I'm going to use it. Then nobody understands you. I think your purpose is to communicate, right? E-books, yeah, nowadays. We have more and more e-books. I have a chance to talk to a big publisher, the CEO, to talk about this e-book. And the question I asked him was, are those e-books going to totally replace the paper published book? And the CEO replies, no, not in the future, as you can see. He thinks both e-books and paper books are going to be coexist for a long time. That's what I think. I kind of agree here. Me, myself, I publish books. I publish paper books. And I also have all the content put it under the internet for free. So that's like e-book. So I asked publisher to publish paper books. Then I gave it to library. So the library have my book. And I also have a soft copy posted on the internet. So everybody can go there and see it. Then people say, Dr. Wu, what's your problem? It's not my problem here. If you want to publish a book, depends on what you want. You want to be kept, then you give it to the library. You give it to your friend. After a while, you ask them, hey, where's my book? Where's what? What? Have you gave me a books? I don't recall. So it won't work that way. It won't work that way. So you need to give it to the library. And library, most likely they will keep it. And later on, they're going to turn out to be digital. They're going to digitalize your book. Then your book going to have a software copy. He said, hey, I have an e-book. I give it to the library. Some library, they still use a paper book. They say, no, we don't really accept any e-books in your format, which is maybe a Word format here. So we don't do that. So that's why, for me, I publish books and I publish e-books by myself. That's your e-books readers here. That's very cool. Amazon have a Kindle. Barnes & Noble have a Nook here. Gaming console here. Oh, gaming has been changed a lot. I also teach gaming, so I can talk a little bit about gaming here. Used to be proprietary. Each company have their console, like Nintendo, PlayStation, that's Xbox, it's Nintendo Switch, Microsoft Xbox, yeah, Sony PlayStation, yeah, that's you use one game, that's for Sony PlayStation. You're going to put it to your Microsoft Xbox One. It won't work. It's not compatible. Right now, there's new trend to get rid of those platforms. They're going to be internet-based. If you use a mobile phone, use your computer to play a computer game, which is somewhere in the internet. You don't care about your platform. You use a Mac, Apple computer, you use a computer with Windows operating system or Linux operating system. Make no difference. You can use it. So that's the new trend here. So that's the gaming new trend. Another trend of gaming is you're going to see more and more computer games used by or designed for mobile phone. The reason is very easy. You carry your mobile phone 24 hours a day. In the early morning, who wake you up? Your alarm clock of your mobile phone, right? So you carry your mobile phone. You don't carry your notebook. or iPad 24 hours a day. No, you don't do that here. So that's why. If you carry a mobile phone 24 hours a day, the new technology, they're going to go to your mobile phone. The games, they're going to go to your mobile phone and ask you to use your mobile phone and play it. Because if you play the game, they're making some money, maybe give you some ad or charge you for playing their games here. But you're going to say, Dr. Wu, mobile phone is too small, a little bit tiny. I like to play in a computer, it's a big screen. Of course, you're right. But thinking about young generation, the kids, they have a mobile phone. They don't have a PC. Or think about some old generation. They have iPhone, they have mobile phone, they have an iPad, tablet. They don't have a computer. So think about them. They're very, very old, very, very young. Mobile phone may be a better choice. And companies which makes computer games, they want to reach young people or old people, maybe reaching a mobile phone instead of computer. Not mention about platform base. You're not going to see a young kid to say, hey, I want to buy a PlayStation, I want to buy an Xbox. It's disappearing. They're going to say, hey, I want to use my mobile phone to play computer games. You're not going to see an old guy to do that either. They're going to use their mobile phone to do it. So this is the new trend for gaming. Smart TV. Oh, smart TV is very, very cool here. Smart TV is a TV connecting to internet. So you see here, Netflix here. Hey, you go to YouTube, you want to search, you type in the keyword. So would that remind you of a computer? This smart TV is actually look like a computer in terms of Googling, viewing like a DVD player, moving a picture or serving or finding some film or video recording on the internet. So you can do that. It's a big screen here. And not expensive. It used to be very expensive, and now the price has been dropped. So that's your TV. See here, Apple TV, Chromecast TV, so on and so forth. Home automation. Oh, this home automation stuff here. Well, they still have the good old security function here. Some people break in, alarm will sound, and they add in some comfortable temperature. They know you are about home, so they adjust the temperature. Good lighting. They know you are going to be home, so they adjust lighting. Appliance here. Appliance here is something funny here. It's appliances for you have freezer. Freezer, they have some food here. You're about to run out some food. Then your freezer going to alert you. That's alerting, including talk to you. So starting to hear your freezer talk to you, say, hey, buy more eggs here. We are kind of run out of eggs here. You say, whoa, whoa, whoa. I don't want my freezer to talk to me. That's the case here. You guys know that your air conditioner, one is outside, that air conditioner, when they are about to run out of freon, or their time for them to get maintenance, they have an IP address, they have Wi-Fi, they can send automatically via the wireless network to the maintenance company. Then your maintenance company gonna call you. Say, Dr. Wu, I say, what? Your air conditioner just called us, said that needs something to, someone need to come over here and to do something. I say, whoa, my air conditioner talk to you, huh? How about my freezer? So that's a new stuff. That's called machine and machine communication. They bypass you. They don't need you. You say, no, I don't think so. Yes, they are. You're driving a car, a new car, a good car here. They can automatically brake. They're going to about hit someone, hit a wall here. They're going to automatically brake on you. Maybe you fall asleep. Maybe you are texting. Maybe your mind somewhere else here. The car can see that danger. That's a wall. You are going to hit it if we don't do nothing. We means the car and you. So the car will do it for you. Yep, that's a machine. So I think we know that. Smart speakers, oh, that's cool stuff here. And the smart speakers is voice activated. You can talk to your speaker and to say, hey, play some music here. Play Willie Nelson. That's something I like. Play some country. Okay, Willie Nelson. Okay, they'll play it for you here. How about that? How can they do it? Voice activated. It's voice to text here. You have your voice, they can change to text here, or using the text, computer can match Willie Nelson here. Yeah. When you input, or they see that we have Willie Nelson, we have country, then you set that keyword, the voice to text, text to voice, they're going to play that for you. That's something new, something very, very cool. Good quality, small space occupying, and not expensive. Oh, let's talk about automatic vehicle. They give you an example of Tesla here. Yeah, I don't have a Tesla. My friend got a Tesla. My friend gave me a ride sometime with the Tesla here. And last time I would see that it was like, they have air conditioner here, air conditioner for my side here. It's a screen. They have a big computer screen here, big monitor screen here. So they show it to me, say, hey, you can adjust the air, the AC gonna blow on you or on your side or something like that here. It's fancy stuff. Touch screen, you can touch or stop it or change where they want to blow it. I said, whoa, that's cool, huh? So that's something new here, Tesla here. And Tesla here also offer a semi-automatic driving. You can ask the car to drive. We all heard the urban legend. Some people got lazy, ask the car to drive for them. They don't drive. That may be a bad idea right now because it's not really mature technology here. You're going to risk your life and other people's life here. So far, at this moment, those computer software can help us to preventing some problems here and not to take over us as a driver, not yet. In the future, most likely it will, right? It will. The driverless car here, you go there and read your comics book and computer say, I go from Dallas to Houston. Okay, after 4.5 hours, you are there. You read your comics book, view your movies, do your texting here. That's in the future, not yet. So be careful about technology. Know your technology. That's something I would like to share with you for this lecture.